Hello world, it's Siraj, and I've built an app called HealthPass. HealthPass is a secure cloud store for all of your medical record data. It doesn't matter where you are in the world. You can be in the United States or Sudan or Japan, any country, and this one app will store all of your health record data very securely using Bitcoin's blockchain technology. There's a lot of hype going on right now around Bitcoin and blockchain because it's rallying right now. So there's a lot of just fluff and there's a lot of hype and there's a lot of things that are not true and there's a lot of people getting scammed. So the point of this video is to show you a real world demo of how Bitcoin's blockchain technology can be used to empower other people and help you create a sustainable business, no matter where you are in the world. Here we go with the demo. So the way HealthPass works is, first of all, you have to sign up. And when you sign up, it's going to ask you, are you a patient or are you a provider? So what I'm doing is I'm building a marketplace here. By the way, the code for all of this is in the video description. I want you to take it and turn it into a profitable business or use the ideas you learn from this to create some other type of related business in blockchain technology. And it's using AI as well, a lot. So here we go. So once you select sign up, you can say, I'm a patient or I'm a provider. So let's just say I'm a patient. So if you're a patient, it's going to ask you a bunch of, patient related info, that, where you live, who you are. If you're a provider, it's going to ask you for your physician license number, any kind of unique identifier that shows that you are indeed who you say you are, a physician. And what we're going to do on the back end as a service is we're going to make sure to validate all of those physicians. So we're building a marketplace here of both. So let's assume that, I am a patient and I've already signed up, I've registered, and now I'm going to log in as a patient. So once I've logged in as a patient, what it's going to do is it's going to show me a dashboard of all of my electronic health record data from everywhere I've visited before. Now I have to either upload this data myself or I have to get the provider to upload that data. So I'll show you how that's going to work. But this is the dashboard, okay? So there's a lot of technology on this page right now. I know it doesn't seem like a lot, but there's a lot of technology on this page. So first of all, what I can do is I can see my health record. So this is a little JavaScript visualization that I used that will show you all of your health data, but in this nice JavaScripty way that shows all of your symptoms, your medications, your personal history, your medical history, your vital signs, your diagnostics, your diseases, everything related to your electronic health record data, EHR. By the way, this is not HIPAA compliant, HIPAA. Not yet. That's V2, V3, whatever. So this is just showing you a proof of concept of how to use this, right? So anyway, so this is my electronic health record data. It's visualized using JavaScript and I can view it. I can actually see my own data. So that's one of the values this brings. Now here's the cool part. Get ready for this. So what I can do is if I have my paper electronic health record, I can upload it to this website and now it's going to load it up. It's going to perform optical character recognition on that. So what I've done is I've taken this health record right here. This is just a sample personal health record. It's a PDF, it's an image. It's actually an image of a PDF, it's a JPEG. And, assuming that I have a phone and I have my, I asked for a copy of my health record, which doctors, at least in the US, are required to give it to you if you ask. And, it's probably the same in a lot of other countries. But once you have that paper record, you could take a picture of it with your phone and then you can drag and drop it into here. Now look at what it's done. It has automatically performed optical character recognition on that image. It's taken all of those details from that. And now, once it's taken all those details, I can submit it to this cloud store. Now, when it's submitting, what it's actually doing is it's storing it in AWS in a secure cloud store. But before it stores it, it is encrypting it with a hash. Now, this is a SHA-256 encryption scheme that what it does is once it's encrypted using SHA-256, then what it does is it timestamps it on the Bitcoin blockchain. So here's a service I found called Proof of Existence. And the way Proof of Existence works is you can have any document you want. Let's just say it's the health record. I'll drag and drop it there. What it's going to do is it's going to encrypt it using SHA-256. It's one of the many encryption schemes out there, okay? Don't worry if you don't know what that is. And the result of that is it's going to output a 25 character hash that you're seeing here. Now, the important thing about this hash is it is a hash that signifies what is inside of that file. So what happens is if you modify that file in any way, if you even change a single 0 or 1 in that file source code, eventually, if you try to encrypt it again, that hash, that 25 character hash, is going to be different. So what that hash actually is it is proof of the density of that data. It is proof of the incorruptibility of that data. So the point of this is that once it's encrypted, yes, the data is not stored on the Bitcoin blockchain. It's stored on my server, but it's encrypted client side. The hash is what's sent to the Bitcoin blockchain. And so here's the cool part. Because the hash of my electronic health record lives on the Bitcoin blockchain, the provider can be certain that I, as a third-party cloud storage service, cannot modify that data. Even if I somehow decrypt the data on my own server, it's encrypted client side. Even if I were to modify it in any way, once the provider downloads that electronic health record, it will the hash will be different because it's going to query the Bitcoin blockchain and match both hashes. Now, if I modified it in any way, that shows that the hash will be different. Okay, that's my point. The hash will be different if I modified it. So what this allows a provider to do is to trust me as somebody who is, he doesn't know, this provider or she, they don't know, but I'm storing all of this valuable data. But the reason they can trust me is because they're taking that trust and they've offloaded it onto the Bitcoin blockchain. Now, why should they trust the Bitcoin blockchain? Because for over a decade now, it's been a decade, this network has proven to be incorruptible, immutable, because it would require more computing power, and I've said this many times before, it would require more computing power than the 500 fastest supercomputers in the world combined in order to modify anything in that blockchain. So it is what's called immutable in computer science terminology, or unchangeable. So this is a great use case of using the blockchain to timestamp. Think of it as like a digital stone where you're inscribing in stone the health record data. And because it's inscribed in stone, it's digital stone, no one can change it. So you know that you can trust whoever is storing it, because you can just see on this public database that we call the blockchain, with all of these transactions coming in every 5 seconds, we can trust that nobody has modified this. So that's what's happened when I have uploaded that to the server. It's performed optical character recognition on that PDF or image. It has extracted all the text. And then here's the second part about the AI. Then it can't just take all that random text and store it just brutally in a brute force way in a database. It's got to know what is every piece of text. What are all these, what do all of these keywords mean? What is a blood group? What is an insurance agent? What is a name and a personal detail and all of this? So that's where keyword recognition comes in. And for that, I use a tool called BioBert, which I've been using a lot. Okay, so that's how and this is quite a long demo. There's actually quite a lot for me to explain here. This is non-trivial, but it's a real use case of this. And here's the thing. If I can't find my provider, I can say hello at USA.com, whatever the provider's email is, and it's going to email that provider to join this network, okay? So we as a service will email them. So that's how it looks for a patient. And then for a provider, the way it works for a provider is they can enter a patient's name. Let's say they're looking for me, and then it's going to show up right there. And then the provider can then see all of that health record data. And if the provider wanted to, they could submit a health record the exact same way right to our service. Now you might be thinking, how much is it charging? How much are you charging these people? Well, the idea is that patients pay $20 a month to use this service, to have an app to access all of your health data at any time in a secure way. And providers, it's a freemium model for them. So it's free to try because we want to build that marketplace of providers. But if you want to upload unlimited electronic health records, then it costs $100 USD to store that data a month. Now, providers right now, they store their data locally in their own server, or it's a mess. So what we want to do is we want to make that whole process more efficient. We're saving providers and patients time, money, and energy, and that is the value that we're bringing to them. So remember, the Bitcoin blockchain is actually a small part of this large app that actually contains a lot of technologies. And so there are 3 learning objectives in this video. The first one is how and when to use the Bitcoin blockchain. The second one is how does optical character recognition work in 2019? And the third is how modern keyword recognition works. So it's 2 AI topics, 1 blockchain topic. We've got a lot to cover in this video. Don't go anywhere. Sit down, relax, enjoy. I'm going to show you exactly how to do this. So in terms of the tools that I use to build this app, I use node.js to build the backend for this app. And the reason I use Node as opposed to, say, Flutter is because right now optical character recognition is kind of broken in Flutter, and I had to build this in 2 days, and I did not have time to wait. So I went straight to JavaScript, where there's this beautiful library called Tesseract.js that performs optical character recognition so simply, and I'll show you how that works. And we built off of that repo, and we added in all of these other integrations like Firebase for user accounts and storage. For payments, Stripe doesn't cover that many countries, but it does cover credit and debit card payments. PayPal does cover over 200 countries, so that's a good thing. And then we also used not Coinbase, but proof of existence, which is, I was actually thinking of using Coinbase, but they don't have this particular functionality that I wanted. And so we're using proof of existence API. They've got this great API. And also I created a Bitcoin wallet inside of the app to be able to send some money to myself. So remember, patients and providers are not paying with Bitcoin. They're paying with fiat currency. In fact, they have no idea that Bitcoin is used in any way here, right? They just know that Bitcoin is there as a ledger, as a proof of existence, basically. They're not transacting in it. And that's how I think we're going to be able to bring this technology into the mainstream, by not overhyping it and saying, oh, it's Bitcoin this and everything is Bitcoin. No. Here is a healthcare app. I'm saying it's Bitcoin here because we're developers here. We're building this technology. But when we're presenting it to end users, you don't have to say, they don't care, right? They want something that's going to work for them. So you find a pain point and you solve it. So I'm using that for the blockchain functionality, Tesseract.js for that optical character recognition, as you're seeing here, right from images, reading the text right out of an image. It's super cool. For keyword recognition, I'm using BioBert. I keep using this amazing model. For visualizing it, there's actually a beautiful JavaScript library for visualizing electronic health record data, incredibly. And lastly, for sending that mail to the provider, if they don't already exist in our database and we want to add them as a patient, I use Node Mailer. All right, so those are the tools. Now let's design what this app looks like using the whiteboard. Okay, so how do we want this app to work? Well, we know that we want there to be that obvious, boilerplate user login sign up page, right? So we have our logo, we have our username field, we have our password field, login, and sign up. But the difference this time is when we create this login sign up page, it's actually not going to be just one sign up page. We want 2 because there are 2 different types of users that we want. And this is good to think of it in this way because as we design what's called our schema for our database, Firebase, we need to know this. So there's going to be 2 different types of users. So let's first start off with the patient, and then we'll go to the provider. So for the patient, it's going to have all of that basic info. Oh my God. It's going to have all of that basic info that we talked about, just user, pass, their address, and what else do we need from the patient? Perhaps that's it really. Oh, of course there are credit card details if they have that, or their PayPal address, or one of the 2. So we want their payment details right there. We're going to capture it right when because remember, it's $20 a month to sign up. For a provider, it'll be the same stuff, no payment details, but the difference is we're going to ask for their license. So that way we can verify them with some kind of government database or wherever that license is stored. So remember, this is not a decentralized app. This is a centralized app that's using blockchain technology. People would actually use this. So that's what matters in the end. So patient, provider, sign up pages, great. So let's assume we've signed up. By the way, we need that nav bar. So now let's do the 2 flows here. So the first flow is going to be the patient flow. So assume that I've logged in as a patient. So here's what it looks like for a patient. For a patient, it's going to show all of my health record data as a table. So there's going to be some kind of table view here, table view, that will be pulling from the database and displaying it asynchronously. So the user doesn't have to wait, it just shows up. Now, when we click on that, it's going to have this modal pop-up. And inside the modal pop-up, we want to show the data inside that's nested inside of that row in our database. And that data is going to be all the electronic health record data. Assume we've performed keyword recognition on it and we have neatly divided all of that data up into string categories that contain all of the essential parts of it that we want. Then we're going to visualize that with JavaScript. And then we have our electronic health record data. We have our upload, drag and drop form to add new data to it, and a submit form to add that to the database. So that's it for the patient. For the provider then, what's it going to look like? Well, for the provider, it's going to have the same thing. They can search for any patient in our database. If the patient shows up, it's going to show all of their electronic health record data. We could reuse this table view that we created up here, and then we can also just reuse this as well, this drag and drop form. So we'll reuse both because they need both things. The difference is they have a search engine to find all the patients that they need. And of course, there's a nav bar, and they have their dashboard. Okay, so pretty simple stuff. And to do this, we're going to use Firebase, we're going to use proof of existence, we're going to use optical character recognition, and then keyword recognition. Once we've recognized those characters, we want to classify them into the types of concepts that they are, be them symptoms, or be they, it could be symptoms, or it could be, medications, or it could be a lot. So that's what's happening on the back end, and that's kind of the basic flow for this app. So let's start with building this app, starting with the optical character recognition bit, because that seems like the hardest bit. So we'll start with that. All right, now that we've done that, let's go ahead and start with that optical character recognition repository. So I found this on the web. It is by NAPTA. Thank you, NAPTA. And what it is, it's called Tesseract.js. It is an optical character recognition library. They've got online demos right in the browser of this technology, which is great. That's amazing that they did this in JavaScript. Here's the English demo. And right there, it's like actually recognizing the text. You can see that right there. But let's just do this ourselves. Let's do this ourselves in our browser. So what we'll do is they've got some instructions here on how to install it. So you just clone it, and then so we're gonna look at these instructions. Let's do this together, okay? Even though I've already done this. CD back, make a direct, hold on. Let me make this bigger so you can see what I'm doing here. Linux shell commands, who's ready for Linux shell commands? So first we wanna make a directory, and we're gonna call it Bitcoin. And then once we're in that directory, we CD'd in, there's nothing here. So we'll initialize an empty Git repository, of course. And once we've done that, we're gonna clone this repository into the folder that we've created. It's going to pull it from GitHub once we've initialized the GitHub repository, and then we're gonna perform the rest of these installation instructions, npm install and npm start. If you don't have npm installed on your machine, go to npmjs.com, and they have some, oh no, it's not npmjs.com. It's install npm. Get npm, there we go. Good. Okay, so just go to that and you'll install it. All right, so there we go, we got it. All right, so now that we've got it, let's go ahead and install it. So we're gonna we're gonna do exactly what it says, cd into that. Okay, I'm inside of tesseract.js. By the way, bad idea to name a folder a .js. So anyway, and then we're gonna do npm install. Now here's the thing about npm. I don't like npm because it never works. So instead I use yarn, which is another package manager for Node. As you can see, it's beautifully working here, unlike npm. Sorry, npm, not sorry. But yarn is amazing, okay? So it always works, and you can get yarn by Googling yarn install instructions. So now it's gonna download all those packages, and then I can start the app, hopefully. All right, so once it's installed, then I'll do npm start, because just for starting it, I can do that. And then hopefully it works. Of course not. Oh, it's because it's already running over here. Let me pause that. Oh, I've got to delete the window too. Oh my gosh. Okay, fine. There we go. Okay, here we go. Okay, there we go. Now, let's choose our file. Let's see our health record file. Okay, amazing, 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 amazing. There is our health record stuff, your blood group, your interest agent. Remember, this is a JPEG. This is an image, okay? And it doesn't mean that it actually has to be an image when it starts. It could be a PDF, it could be a physical paper copy, but just turn it into an image, feed it into this, and we've got that, okay? So this is a great boilerplate app because this functionality looks challenging to build from scratch. Yes, we could do it, but we want to build something as fast as possible. So we're going to start with this and we're going to build off of it. So this is our base repository. Let's take a look around here. And using Sublime, what is in here? Oh, so this is the old one. So what do we got here? We've got our source, we've got our browser, index.js. Okay, we've got common. Okay, these we don't care about. Common is like all the hard mathy stuff that we don't need to worry about. Work, index, scripts, server. Aha. Okay. So in here, we're going to add a route. And the route is going to be, let's see. What I want to do is I want to create a new route. So I'll say right at that beginning page, I'm going to say this app is going to be called login.html. So I'll have to create that login.html file. So I'll say new file, hello, and I'll save it as login.html. Okay, so now that we've installed it locally, let's talk about how it works. So the thing about optical character recognition is that it's not a new concept. It's been around for quite a while. But you know, computer vision in general, just a note on computer vision research for the past 30 years has been largely discarded because of the power of deep learning, specifically convolutional neural networks, when given a lot of data and a lot of compute, outperform all of the other algorithms. What I mean is that there was an entire theory around computer vision that involved all sorts of techniques, from filtering techniques to finding contours and all this stuff. And what's happened is that deep learning has kind of made all of that irrelevant. But let me talk about it for a second. So what happens is the problem that we are trying to solve with optical character recognition is we have some image, and in that image there is some text, like you see here. And we want to automatically, digitally transcribe that text that lives in the real world, be it in newspapers or magazines, into a text file, okay? So there's the way this was done classically with, say, OpenCV or one of these traditional computer vision libraries is that step one is to apply filters to that image to make those characters stand out more. And there are a whole bunch of different filters, as you can see here, that we could try. This step two then is once we have a proper filter that kind of makes those characters stick out, we can apply contour detection to recognize those characters one by one. So what you're seeing here is a slot machine, and those characters are more precisely drawn out. And once we do that, we can segment those characters in particular, cut out everything else, and then perform image classification on those segmented characters with a model that's been trained, a convolutional network, would say for MNIST or what have you, to then detect all of those characters, right? So that's the general idea. The problem is that contour detection is quite a challenging task, and the whole thing is challenging, really. I mean, optical OCR, or we're going to call it OCR. OCR has not been solved yet, right? So as you see here, this just classified an 8 and a 4. It didn't notice that these are actually two disparate, separate numbers. So this paper just came out 20 days ago and it's still trying to achieve state of the art in optical character recognition. So this technology works. There are applications that use it in the real world, but it is not perfect. So this is totally a great place to do any kind of research or to do any kind of application-based programming as well. So the solution to getting this stuff to be better, as was the case in this paper, and it's what we're going to do in this video, is to use sequence-to-sequence modeling. The idea is that you have some input sequence. It could be characters, it could be images, it could be anything, some sequence, and you output a sequence. So you have two different models, okay? And so these two different neural networks usually can be any kind of network. And we call one the encoder, we call one the decoder. Good, I hope you got that. Right, and so deep learning dominates the sequence modeling space. And so what we're going to do is we're going to use a convolutional network to understand the image data and build representations of it in the form of matrices that store that data. That's the brain of the neural network. And then we're going to use a recurrent network to output a sequence of characters. So the way this works is that the convolutional layers will help in extracting the relevant information and storing those as feature maps. We'll then feed those feature maps into a recurrent network, specifically a deep bidirectional long short-term memory network. And what that's going to do is it's going to be able to capture the contextual information. So say it's trying to recognize the word state. It's going to know that A is between T and T, right? It's going to look in both directions. And this is good for accuracy. For example, BERT, the popular model I talked about last week, does this as well. We'll talk about that later. And it's going to output these predicted sequence. Now you might be thinking, well, how is it going to actually know that state actually, when I read it in the image, it comes out to this predicted sequence? Because we are training it on a labeled data set of images. Like, let's say we have one of the images as state in one column and the other column is going to be the word state. And so it's going to learn the mapping of that, all right? So recurrent network and convolutional network, we need both. And that's the idea. Now, there's also, by the way, if you want to learn more about these two networks, just search convolutional network Siraj or recurrent network Siraj. Both I have great videos on, many. So the third thing I want to talk about is attention. Okay, so when we are reading an image or we are reading a person's face or we're reading anything with our minds, we are paying attention to specific parts that we have learned to be the most relevant, to be able to make a prediction. And so we can encode that ability into these machines by using a different set of matrices, of weight values, right? And so that's what attention really is, attention mechanisms, and there are all sorts of attention mechanisms out there. What they really do is they allow the neural network or whatever architecture you have to learn what part of the image or text or sequence is the most relevant for the objective that you defined. And the way it knows that is because it is updated via calculus, just like the rest of your weights. Search backpropagation Siraj to learn more about how backpropagation works. Okay, so this is going to use an attention model. Now, the way that this works in terms of code, like how do we build this attention-based optical character recognition, sequence-to-sequence deep learning model that uses convolutional networks and a recurrent network? Here's some TensorFlow code, okay? So let's just briefly go over this. We're not gonna build this from scratch, but here's the code for it. It's called Attention OCR on GitHub. So there's a lot of code here, but basically, we can see that we are creating an encoder right here and a decoder. And then we are setting the encoder to be that convolutional network and the decoder to be the recurrent network. We are applying attention, we're training it on some data, yada, yada, yada. This is quite a lot of code. We don't have time to go over 500 lines of code in this video, but that's how it works. Link is going to be in the description, okay? That's the idea. That's what's already built into our app. We didn't have to do anything. Now we can build that boilerplate login sign-up page for the provider and patient. Let's do this. So inside of server.js, what I can do is I can add a route that says I want to go to this login.html page right at that beginning. Because remember, in that demo, there was no login page. I had to manually go to that demo via the URL. So we're going to set that index page to login. And so we're going to add some text right here into login.html. Now, CSS and HTML is very simple, boilerplate, and you can learn this anywhere. You know, I don't think it's very valuable for me to type out all this just raw HTML, like HTML, and then, you know, like the body, and then inside there's like the body of the HTML. You know, this is pretty, I mean, it's fun for sure. HTML is fun, but, you know, it's not super hard. Hello, and there's my basic HTML. Okay, and then if I want to add some JavaScript, I'll say, here's my script, and then I'll add some JavaScript in there. Yo, okay, and then that ends my JavaScript. And if I want to add some CSS to this, I'll say style. I think it's style, and then I'll add in some CSS. Okay, so CSS styles it, JavaScript gives it the logic and the brains, and HTML lays everything out. Okay, so let's find some boilerplate login page and add it in. In fact, I've got one. What's it called? This is a great thing about making a lot of apps is you can just reuse stuff. It was called Watch Me Build a Healthcare. Watch me build Watch me build an AI startup. And in that, hello world, I used, it's so weird looking at my own videos. It's like, it's weird. Anyway, here's the code. What's going on here? Oh, here's his boilerplate Flask code. And then, great, he's got all this stuff. So I'm just gonna take this login page right here and use it, but not the, obviously not the Python part, because we're doing this in JavaScript. Okay, so here is the login page that I've created. I've created, first of all, a nav bar, and then below the nav bar, I've added the image for the logo, and I got that image using what is called brandmark.io, which allows you to automatically generate your logo, which is awesome. And so I went to Health Pass, logo, I already talked about this. I don't want to show you again, but you can easily generate a logo. So then once I generate my logo, I'll add in my username field, my password, my checkbox, I added some style into via the CSS. And yeah, that's basically it. It's like a very simple, here's like all these Health Pass logos. I'll just be like, yeah, very simple. So, so we have that. Here's my login page, and then I want there to be a provider page. So when you hit sign up, patient or provider, and it will show you a different page. So notice I've got two different pages, a provider sign up page and a patient page. And if I wanted to be really fancy, then I wouldn't create two HTML pages, but one layout, and then have that layout be a model from which views are created. And that'd be a better way of doing this, but I'm just moving really fast here. So I'm just trying to build something as fast as possible. So we get back to home, we get back to login, and then, okay, so right, so once the user signs up and they have entered their information, then what do we want? Once we've created that login page, sign up page, we want to add Stripe and PayPal functionality. So all we have to do is go to Stripe NPM or PayPal NPM. We then install those clients directly into our package. We'll use Yarn, but the NPM page has a lot of great stuff here. And then we will add that to our form. So we are creating a custom form. We want to take that data, send it to Stripe, so that we store that user's payment token, and then using that payment token, we can just, instead of storing the card details ourselves, which would require authorization, we can just store Stripe is storing it. So we just have that identifier that's stored in our database. So we don't need any of that. They take care of that complexity. Okay, so we'll do npm install Stripe, npm install Stripe. Of course it's not gonna work. Watch it not work. Okay, sudo yarn add Stripe. Come on, let's go. Come on. Yes, okay, so that's for Stripe. And then we want PayPal as well. So here, see, and the examples are here. And we want PayPal. Okay. No, not this ghetto one. We want a good one. We want a good PayPal checkout, right? Look at this. You just add in the script. You have a checkout button. Can you guys make it any easier? Thank you, PayPal, for making it easy. Thank you. I would use Braintree, that my friend has that startup, but yo, Braintree's cool too, but that's okay. Okay, yes. So for PayPal, we just need to add in this. So Stripe is installed. Now for PayPal, we just add this to our page. And then we drop the following component into our page, and that's it. And now we have a checkout button. Oh, but that doesn't work. So we'll just have to manually add it via demo app source. Hopefully they have a GitHub link. Yep. Okay. Source app server, source app server, app.js. Yep. Page, index. There we go. Cool. So anyway, we will add that into our script. We'll add it in right here, script. Okay, so there we go. So now we've got a checkout. Okay. Okay, so that's it for Stripe and PayPal functionality and that boilerplate stuff. So now, how and when to use the Bitcoin blockchain. Okay, so first of all, I have this great video. If you don't know anything about blockchain, just watch this simple blockchain in 5 minutes. I build one in 5 minutes. Go watch that, pause this, and then come back here, okay? I also have a course called Decentralized Applications. It's free. It's at the School of AI. I also wrote a book called Decentralized Applications. So my point in saying all this is not just a flex. It's to show you that I have been thinking about this for years, okay? And before I talk about how and when to use the Bitcoin blockchain, I want to rap about it. So here we go. Here's a 10-second rap. Here we go. Bitcoin's back and it's 2019. It never went away. It's behind the scenes. Shout out to SHR256. Shout out to the devs whose bugs get fixed. Bitcoin's back and in 2019. It never went away. It's behind the scenes. Okay, I hope you enjoyed that rap. Now let's get back to this. There are a lot of applications of Bitcoin's blockchain technology, okay? There's a lot. And so we want to think about those applications that are super, super valuable, right? How can we save people time, money, and energy? People who don't think about Bitcoin or blockchain or any of these things. How can we reach them, right? Because Bitcoin has an association with drugs and negative things like that. And we don't want that negativity associated with our app. We want to meet people where they're at rather than having them come to where we're at. And that's how we're going to be successful with this. So there's a lot of use cases, but anytime we can, anytime there's a lot of trust that's required and that trust is oftentimes misused, that is a good use case. So supply chains, lots of disparate nodes in the supply chain. They're all trying to come to consensus and agreement on when something has been sent, when something has been delayed, whether or not a driver properly sent this on time, whether they were late. There's a lot of trust all the way down the chain. And so there's a lot of supply chain companies out there, and they're using a centralized database for all of this. And sometimes there are different databases, and it just gets into this mess. If there was one immutable, unchangeable database that you can store all timestamps of everywhere a product or shipment has been, that everybody can verify using blockchain.com, that's a perfect use case, right? So supply chain, anything having to do with legalities. So, having a notary, any kind of legal document that you want to live and be permanent rather than having to go to court, you can put it on the blockchain. Any kind of registry, anything having to do with health records or any kind of sensitive data that so medicine is a big one, and DeepMind is actually working on something like this, but there's a lot of opportunity in this space. Medicine, supply chain, legalities, government, governance, and anything else having to do with trust. There's quite a lot of potential here. I'm talking about things outside of finance. So inside of finance, there's a lot of opportunity that's obvious, whether it be asset prediction or trading bots or all this stuff. But I'm talking about outside of finance, and there's a lot of those as well. Okay, so now we're going to integrate that service that I talked about, that timestamping service, and then we're going to add in Firebase and then keyword recognition, all right? So if we go to the website, proof of existence, written forever, great. They've got a little demo right there. So I can just go ahead and put in that health record of mine and see what happens. So what's happening here is they're not storing that health record. They have encrypted it using an encryption scheme called SHA-256 that will create a 25-character hash, and then it's going to store that hash in the Bitcoin blockchain using a type of transaction using Bitcoin scripting language. So they have offloaded that. And then we have this API that we're accessing via our browser that can make that request. Now I have to pay for this, right? So there is a payment here. So what happens is what we're going to have to do is in our app, once we use this, so obviously we need an API for this. And luckily for us, they have one. They have a GitHub repository. They have some documents as well. Okay, so it's a blockchain notary service. We want to use our API. And okay, so they've got some commands we can do to timestamp it, great, and then create a SHA-256 hash. So first, we want to integrate this JavaScript library called crypto.js, which will create a hash for us based on our data, that image. Once we have that hash, we're going to send it to this service. It's going to require us to pay. In order for us to pay, we're going to need to create a Bitcoin wallet that can then pay this address. Okay, so in order for us to do that, we're going to have to integrate that Bitcoin wallet JavaScript, and hopefully there's a good one out there. It's called Bcoin. It's very reliable. It's got a lot of stars. It is actively being updated. This is good. And so this is a Bitcoin node that we can store in our app. And once we have this node in our app, we can then send Bitcoin to this service. And so this is an example right here in the browser of a Bitcoin node. It's showing all of this blockchain data. It's showing the ability to send Bitcoin to some address. It's a pretty cool demo right here, like real-time Bitcoin right here. Okay, so I'll send some amount, I'll hit send, and it's gonna do that. Great, so we want that functionality to be able to send to this service. So we'll first integrate Bitcoin, Bcoin, this like JavaScript client. So we'll do npm install of all of those dependencies. Then we will use that to create a request using some JavaScript request library that would encapsulate the curl command. And once we do that, we're going to make that request to the proof of existence, and we'll use Ajax for that probably. And then once we do that, it will return to us that hash, and that is the hash of the transaction that we store in our database. So we're storing two hashes. We're storing the hash of the Bitcoin transaction, and we're storing the hash of the data itself, the SHA-256 hash. And we're storing both of those in our database, all right? So we want to integrate this jQuery here to make a request to this service, okay? So right when, where do we want to do this? Right when the user hits submit. So right in demo.html, in that page, we want to add in this Ajax request. And when we do that, let's see, let's add in that Ajax request right here. Ajax. Okay, and then we'll have to replace that URL with the URL of the proof of existence. API, just like that. And then we're going to have to modify these parameters to fit the parameters of this request here. So there's Bcoin right here. It says to use crypto.js to encrypt the file, and we want to do that as well. So client side will first encrypt the file, then we'll make the request. So we're going to encrypt. So encrypt file, create Bitcoin node, initialize Bitcoin node, init Bitcoin node, and then make proof of existence blockchain timestamp with the data. Okay, and so when we init the Bitcoin node, we want to go back here and we want to see how to do that. So we've got some docs here, and then inside of the docs, getting started, and hopefully there's some code here. We want to create a full node just to start off. Here we go. Boom. That's it. Ha. Easy. Obviously, it's going to have some errors, but this is kind of like the base, and now we're going to modify it to be better. So what we're doing is we encrypt the file, initialize the Bitcoin node, and then make that proof of existence timestamp, return back that hash, and then we're going to store that in Firebase. So that's that first part. Now, before we get to Firebase, let me also talk about how keyword recognition works in this case. So there exist a lot of great keyword recognition functionalities out there, right? So, you know, Google Cloud has this great API for natural language that enables you to perform keyword recognition very easily. And there's this natural language API demo right here that we can try that will say, you know, you can type in any text. It will analyze that text after confirming that you're not a robot. And once it's done that, it's going to show you what each of those words are. What is the category of each of those words? The problem is that this API and no API, actually, none of them, are able to categorize domain-specific terminology for our app. And in our case, let's remember what is the domain-specific terminology. It is personal data. It is your vital signs, it is your symptoms, it is your physicians, it is your family history, it is your medical history. So we need to be able to categorize these medical terms. And so how do we do that? So that's the question. And the way to do that is, again, BioBert. I love this model. BioBert is incredible because it is able to perform a lot of different NLP tasks. And the way it works, if you want to really learn how BioBert works, go right back to my video from last week, how to build a biomedical startup. And what I use it for in that video was to perform keyword recognition as well. So what BioBert does is it performs a lot of different tasks. Name entity recognition is the one that we want. And it was trained on this data via PubMed and a bunch of other medical websites. And so what we want to do is we're going to use that, and hopefully it's going to be able to perform keyword recognition for all of these things, and then we can keep going. But if there is some category that it does not cover, we're going to have to retrain that model on a new data set that either we find or we generate. And remember, for every classification, for every class that we want to be able to categorize, we'll create a database of symptom, not symptom, right? Or for every single one, symptom, not symptom, medication, not medication. So we want a database of medications and all sorts of things, learn the mapping, and then we'll just retrain it for as many new keywords or categories as we want it to be able to classify. And then at the end, it's going to be very robust. And so that's going to be a process, right? So that's the idea behind BERT. We want to retrain it on our own specific medical data. And the other thing is that I want to put this into your mind as well, because this is really cool. What we also want is we want to create a database in real time. So what I mean is the best database is the health records themselves that the patients are uploading to our service. And what we want to do is we want to say, okay, based on this health record and the output of the optical character recognition model and the output of our keyword recognition service, it's going to be pretty good. But at the start, we might want to validate what its output with the users. And the users can manually, the patients can manually adjust what those keywords are and if they're correct or not. And once the users have verified them, that becomes our label. All of that becomes the label to this health record. And so we're building this database over time. And so as we build this, we want to be able to run a model that retrains on this data every, say, 2 weeks or some interval that we decide beforehand. And Tensorflow serving is a great way to make that happen. Now, we don't want our model to be able to train on this data in a way that it can be reverse engineered, or we don't want this model to be trained in a way on this data that allows us as a service to be able to read this, right? Because it's supposed to be encrypted client side. So what we're going to do in this case, in order to train our model in a very secure way that does not involve us learning about this patient's sensitive data, is to use a library called PySift, but a JavaScript version of this. Oh, they have my name on here. That's nice. And so PySift will let you. PySift is incredible. Like, by the way, my friend Andrew Trask has this great course on this called. Definitely take. It's a free course. That's why I'm promoting it. Secure and Private AI for healthcare. This is perfect. Take this course. Okay, it's free. Just take it. All right. So PySift, super cool stuff. So we'll integrate that, but a JavaScript version to ensure that it's all secure. So notice how there's a lot of moving parts here. Like, this is quite a complicated app. There's keyword recognition, there's optical character recognition, there's secure model training, there is the blockchain, and there's visualization. We haven't even gotten to that yet. So there's quite a lot here. But I want to show you how that works. So first I want to show you how we can use BERT as a service. Check out this repository. This person embedded BERT models into TensorFlow serving, which is amazing. Great boilerplate code to look at, BERT as a service. It's got a lot of stars and forks on GitHub, which is great. And we also want to utilize this health visualization functionality. Like, how do we want to present these electronic medical records to users? Because right now they are ugly. So if you look at health records, so any kind of electronic health record, it's like they're all using Windows 92. They're all using like MS-DOS status, like, just not pretty like this. I don't know, it's just like ancient stuff. So we got to upgrade them. It's hard to parse all this data, but what would be ideal is if we're able to just take a screenshot of whatever kind of system they use and then perform our image to text service, our optical character recognition. That way we can parse their ancient system without having to integrate it ourselves. The power of AI. So anyway, so in terms of visualization, I found this great library called Health Figures, H-Figures. And what it does is it shows this visualization of all this healthcare data. They've got a live demo. And so what I did was I just downloaded it and then I iframed it into that modal pop-up. I removed the border so you can't see the border, but it basically already has this functionality. And then once I've added that to the app, users can see it very, very clearly. Okay, so, so I gotta fix that part. But, right, so you can see the health record right there. And so what this is I actually just moved H-Figures, as you can see right here, into my repository. So we can access that right there. And now we have to obviously change the data so it's valid and it's connected to our database, etc., things like that. So I think that's it for this video. There's quite a lot going on in my head right now. As you can see, this is an app that is a starter repository for you. I've laid out the details of how you can improve this app inside of the GitHub repository. Again, the point of this video is to inspire you, to educate you, to build something impactful for yourself, for other people, and make some money using this technology. The code, the ideas, everything free in the GitHub repository, link in the video description. There's a lot of ways to improve this app. We can add keyword recognition, we can add a better interface, we can create a mobile app, which would be great. There's a lot we can do. So I hope you found this video useful, wizards, and if you did, please hit the red subscribe button and you'll get updated every time I release a new video.